First, we want to ask, what is a quadratic inequality? A quadratic inequality is a type of nonlinear inequality where you have a quadratic with a less than, equal to, greater than, equal to 0. So anytime you have something like this, there's a little bit different way that we have to solve it. So there are some similarities. We could go ahead and make this into factors of x minus 5 and x minus 2 less than 0, but that's where the similarities would stop. We can't say because this times this is less than 0 that this is less than 0 or this is less than 0. That's not logically true. For example, if I have a negative 10, I know that is less than 0. But let's say that we factor that as negative 5 times a positive 2 and make that less than 0. Does that also mean that negative 5 is less than 0 or 2 is less than 0? It does not. Instead, what we have to do is to work towards finding critical values and testing intervals around those critical values with a sign chart. So the critical values are taking these factors and setting them equal to 0 and solving. 5 is a critical value, and 2 is a critical value. So our polynomial is going to behave differently in these intervals that are being separated by the critical values of 2 and 5. So let's go ahead and place our factors that we have right there. Anything to the left of 2 is going to act on that polynomial in the same way. So it doesn't matter what number you pick to test over here as long as it comes from that interval. Let's say that we want to test 0. If I put 0 in for x and I subtract 5, that's going to give me a negative result. I don't really care about what the number is. I just want to know what sign that number will have. So trying a 0 here, 0 minus 2 gives me a negative. Now those factors were being multiplied, so we need to go ahead and multiply. A negative times a negative gives us a positive interval. So anything that comes from this interval, any number I would pick from here, if I would use that number for x in my inequality, it would cause that to be positive. Let's try a number in this interval, maybe a 3. If I put 3 in, 3 minus 5 is negative, 3 minus 2 is positive, and a negative times a positive is negative. Let's test something over here, maybe a 6. 6 minus 5 is positive, 6 minus 2 is positive, so a positive times a positive is positive. Now, which interval is it that I want? Notice that our inequality says less than 0. We want any number that we put into the inequality to cause this to be less than 0, or in other words, negative. And we tested on the sign chart and found that anything between 2 and 5 is going to cause that to be a negative. So this is the interval that we want. And would we include 2 or 5? Well, let's think about that. If we use 2, and I put that, say, right here, 2 minus 2 is 0, and 0 times this negative 3 that you would get by putting 2 there is going to be 0. Is 0 less than 0? No. So we're going to have to put a parenthesis. Same goes for the 5. The 5 is going to make the left side of that inequality a 0, and 0 is not less than 0. So we have to put a parenthesis. So our solution set, place an interval notation as 2 to 5, not including 2 or 5. So let's go ahead and practice with a couple of problems. We'll set up a sign chart and graph the solution set and then write our solution set in interval notation. I'll go ahead and factor x minus 7 and x plus 4 is greater than 0. And so then I have critical values of 7, because x minus 7 equals 0 would give me a x equals 7. And negative 4, because x plus 4 equals 0, gives me an x equals negative 4. So I'll go ahead and place those critical values on the number line. Be careful to put them on the number line in the order that they actually appear on the number line. We wouldn't want to put the 7 here and the negative 4. That ends up causing problems for us. Let's list our factors that occur, and then we'll test our 3 intervals. So testing something over here, I might test a negative 5. Negative 5 minus 7 is negative. Negative 5 plus 4 is negative. And a negative times a negative is positive. Testing something over here, maybe a 0. 0 minus 7 is negative. 0 plus 4 is positive, and a negative times a positive is negative. Testing something over here, maybe an 8. 8 minus 7 is positive. 8 plus 4 is positive, and a positive times a positive is positive. Now, which intervals do we want? This says greater than 0, so that means we want positive intervals. That means I'm going to want this interval, and I'm going to want this interval. And I'm not going to include the endpoints because this is a strict inequality, strictly greater than 0, not a greater than or equal to. Then my solution set is negative infinity to negative 4 union 7 to positive infinity. Let's try with this one. This one isn't in a nice format yet. We need to get a 0 on the one side. So let's subtract 3 from both sides. That gives me 2x squared minus 5x minus 3 is greater than equal to 0. Let's go ahead and factor as we did before. And I'm going to have 2x plus 1 and x minus 3 is greater than equal to 0. Let's get the critical values. So 2x plus 1 equals 0. 2x is negative 1 and x is a negative half. X minus 3 equals 0 gives me an x equals 3 as my critical value. So a sign chart here. List the factors 2x plus 1 and x minus 3. Place the critical values on the number line in the order that they would appear on the number line, and then start testing the intervals. Let's test a negative 1. Negative 1 times 2 is negative 2 plus 1 is negative. Negative 1 minus 3 is negative, and a negative times a negative is positive. Testing possibly a 0. 2 times 0, 0 plus 1 is positive. 0 minus 3 is negative, and a positive times a negative is negative. Testing a 4. 2 times 4 is 8 plus 1 is positive. 4 minus 3 is positive, and a positive times a positive is positive. All right, which intervals do we want? This says greater than or equal to 0. So it means I want the positive intervals again. And those happen to be these intervals. And I'm going to include the endpoints with a square bracket this time because of the equal to. In other words, if I use 3 minus 3 is 0. This would be a 2 times 3 is 6 plus 1 is 7. 0 times 7 is 0. And 0 is greater than or equal to 0. So we will include the endpoints that cause this to be equal to 0. The other numbers in the intervals would be the numbers that cause the interval to be greater than 0. So our solution is going to be negative infinity to negative 1/2 union 3 to infinity. And that's our solution for that quadratic inequality. That's all.